beyond simulation, how industrial AI supercharges the digital twin. So 2 buzzwords in one sentence, but so we start very slow that everybody's on board what we are talking about, what is a digital twin. So if we look, and the digital twin is the core, and what we heard, digital twin and simulation is around since years. We are talking digital twin since 10 years already. So, but what is the digital twin? It's a digital representation of a physical asset, of a process or whatever. We have different digital twins, so it speeds up processes, it improves sustainability, and also helps master complexity. But we also talk about the comprehensive digital twin. And why we are talking about the comprehensive digital twin? Because we have different areas where the digital twin is applied. So we have the whole topic about products, product design, and so on, like a car, but also ship, plane, whatever it is, chemicals, liquids. Then we have the digital twin of production. This is also my home turf, right? It's industrial systems. So how we can bring and how we make this on the machine, line, and plant level. And then we have also the digital twin of performance. And if we combine all those, then we have a comprehensive digital twin. And for sure, in each and every of those disciplines, we have different levels of granularity. And now looking into the production, digital twin of production, one step more detailed, we see on the left-hand side the digital world. And the digital world, we have what I mentioned before, they have components. That means we start on a component level with behavior of components. We talk about machine level, we talk about line, plant, until manufacturing execution systems or manufacturing operation management. And important is that we have a real digital world which has the same behavior like the real world. And so in the real world I have a real behavior, in the virtual world and in the digital world I have a simulated, a modeled behavior, and so I need also to assemble all those things together to have then a full digital twin. So this is the digital twin part, so product, production, performance, comprehensive digital twin, real and digital. And now let's have a little bit of baselining about the AI. And we are talking about the consumer AI, we are talking about industrial AI. And what is here the thing? For industrial AI, demands much, much more than we know from a consumer AI. We can't accept failures or anything else. So it needs to be also safe, it needs to be reliable. It needs to be managed complex things and complex dependencies, and this repeatedly in the same quality. And we need to talk also different language, the language of industry. And now let's have a look, what does it mean, how does AI in industry look like, and which kind of AI do we see there? So we have, first of all, in the base, the foundational models, industrial foundational model, where we have data sources and so on. On top, we can connect and build on agents, different agents, but we can also build up an orchestration agent, orchestrating different agents, and then we have the output, the applications, where we have then maybe through large language models or whatever, a copilot helping us to perform tasks, and through the copilot I can manage agents and the agents could manage my tools. But we will see it also later how we bring it then together, and then we have the output. And with this agentic AI topics, we are improving workflows and tasks and multi-domain things. And then we have a second part where we are talking about physical AI, and we are towards more autonomous production, because we need to train and to apply that. In example, a robot knows how he behaves. A robot needs to understand which payload I can handle, which is my range, what can I do, what is working. So we have then also real-world inputs to the robots with sensors, data, maybe video, whatever. And then we have performing some trained AI as a physical AI, and then also output different capabilities, what such a robot or an AGV or whatever can do. So we have now the digital world and digital twin, and we have now a little bit AI. And now let's bring it together, and I have one example with me today, and we go a little bit into what does it mean. If we look, so in the past, or now still nowadays as well, for sure, we have hard-coded tasks. We program something in automation and it will behave and do exactly like we told the system, and we will exactly get the result we coded it for. And then we have now goal-driven tasks. If we talk about these humanoid robots, AMRs, AGVs, or whatever machines and things around, we want to go for goal-driven values and goal-driven workflows. And with these goal-driven workflows, we need something different, and we need somehow to make it happen and to apply it. So let's, one example to go a little bit, how we bring it now together, simulation and digital twin. So we have a virtual, built up, a simulated conveyor. And with this simulated and virtual conveyor, I can test, I can code, I can train something, and so on. On the right hand, we have a real conveyor, and we see then later on the real result. But let's have a look how we come to this and how it is this working. Because we need to train. We now talking about that we program something which is not standardized programmable, because we want randomly getting parcels in, and in the end we need always the same output, with the same speed, with the same topic. So we can do in a virtual world, that means in a simulated world, in the digital world, we can start now training it and doing it before building up something physical. So that means we train our AI in the virtual world. And this we can do then with 10,000, 100,000, 1 million, 10 million cycles to get the best results. And this for sure is then also a combination about what we can then imply into our engineering tools, combine it with electric behavior and automation code. So we can now bring all those things what we have trained before, how the algorithm should work, that we get exactly the result, sorting the parcels with the right speed. I can then bring into my digital twin and validate it again. I can see my performance with NX and Simit and other products. And if we have trained it, and then there's also one more use case to see it, we go a little bit further, and we can now take this algorithm and deploy it into the real world. Yeah? So we have now in the first step, trained this algorithm in the virtual world with 10 million cycles, even in the end 20 million cycles to get really the best result. And then we take this algorithm, which is now trained, proven and tested, and it could apply it to the real world. And we see in the lower side of the slide also that there's a different case. It's not one a straight line belt, so we have now multi-belts. And this is also where we can say, look, you are a conveyor, you are a conveyor belt, and you have different speeds and different sizes, and I can tell basically this conveyor part, what it can do, how it can behave. So I can now take it, bring randomly parcels in on the next level, take a camera, and now the system is self-adopting that in the end, if you look at it, on the right-hand side, all the parcels are in a straight line, they are sorted and turned and everything. So we see here how we bring AI and digital twin together, and why it's so hand in hand, and why it's a super match that we talk about AI together with a digital twin. So what you saw here is one example. But we have more examples in different industries and also in different combination, how AI and digital twins could work together and how they benefit from each other by testing AIs, training AI, multiple things, and so on.